we have, which is a panel that it's moderated by Julie Miller Canuto, apologies, called Using Software to Identify Part Opportunities and Deliver on the Promises of 3D Printing. So Julie, please feel free to cam on, mic on, and all of the panelists, feel free to do the same as well. And likewise, I will send you just a little reminder. Come up to the stage. So Julie, you should have just got yours. Hello, Julie. How are you going?
Hey, Alex. I'm doing okay. Excited for this last presentation before we all go back to the...
I know. Type 3D is nearly finished. All right. So Angelique, I've just sent you a request. Excellent.
I'm here.
Hello. Jennifer, you should have got one. Very good. And Barbara, yours is on the way.
Hello.
Everyone. All right. Julie, I'm going to hand it over to you to introduce your panelists and take it away. Thank you very much.
Excellent. Thanks, Alex. So I'm going to share the screen real quick. So thank you, everyone, for sticking around. I know this is the last panel of the day, last presentation of the day before we all head back over to the main stage to see those closing remarks. I think we've got a really awesome panel lined up here for you guys. So let's just have our panelists introduce themselves. Maybe Jennifer, if you want to start, we'll go through the order on the slide and I'll bring up the rear.
Sure. Thank you, Julie. My name is Jennifer Herron. I'm the CEO and founder of Action Engineering, and we are focused on 3D data transformations. 3D data, of course, includes anything 3D printed. So I am also heavily involved in the product definition standards that surround 3D data. So I'm a board member on the Digital Metrology Standards Consortium and am involved in several of the standards within ASME. And I was the original chair for the ASME product definition for additive manufacturing standard. Thanks.
Barbara, if you want to go next.
Oh, certainly. And hello, everyone. I'm happy to be here. This is my second time presenting on the economics panel, and I'm thrilled to be a part of this group as well as Women in 3D Printing. I have a diverse background that varies from doing injection molding and manufacturing in the plastics industry all the way through 3D printing. I'm one of the first ones, you might say, that was in 3D printing in that I have over 30 years experience in the 3D printing industry. Currently, I do consulting as a director and consultant in PARTS, which stands for Prototyping and Rapid Tooling Services, which has been my company for several years. I'm also a part of OSAClean, which is an injection molding and extrusion purging compound company, a part of the Asaki group of companies. Happy to be here. Thank you.
Hi. I guess I'm the last one. So hi everybody. I'm really excited to be part of this event for years. So my name is Angelique Malizu. I'm the director of business development for Castor. Castor is a software company. What it does is to identify amongst thousands of parts which of those are suitable for additive manufacturing. So ultimately, it answers the question, can this part be printed? And it comes with many considerations. And also, should this part be printed? Meaning, is there a business case? Is it faster? Is it cheaper? Is it better? So this is our main focus. And yeah, really excited about the discussion.
Thanks, everyone. So I'll introduce myself. I'm Julie Miller-Canuto. I'm a technical program manager here at Materialize, focusing on kind of roadmap development for our CO-AM product, our kind of MES solution. And so my background is mainly in qualification of new processes in the aerospace sector. And so my focus now at Materialize is really focusing on how do we bring additive as a whole, and specifically our products, obviously, up to the standards that are required in those industries. And how do we, just like Angeliki was saying, should these parts be printed, helping customers work through that, and kind of how we can use our software to better streamline that process for customers. And so I'm going to be moderating this panel today. Thank you again all for joining. I'm going to stop sharing my screen, and I'm going to launch into some of the questions I prepared for the panel. But if anyone in the audience has any questions as well, feel free to throw those into the Q&A tab. I'll try to keep an eye on over there as we walk through and see where I can work those in. So I always think it's good to kind of jump into the meat of the presentation. So let's start with the question that is kind of in our title. So what advice can you give for how can we really identify legacy or new applications that would benefit from additive? Anyone can jump in, or I can start calling on people.
I'll jump in.
Go.
Part of the reason why I'm going to jump in is because I come from what we call a legacy tradition, in that I have worked in both metalworking and the plastic processing side, specifically if you talk about injection molding. And a lot of times we have customers that come to us and believe it is a one-on-one substitution of additive manufacturing for injection molding parts. I will say sometimes, yeah, could be. But often you have to be careful what you wish for, because injection molding imparts characteristics that you can't get from additive manufacturing. And all of you that have ever listened to me before know that this is a constant theme that I say is just because you can doesn't mean you should. Injection molding gives you characteristics of the part based on the fact of the process packs the part with material. It has heat factors that come into the part that affect the strength, surface characteristics, as well as a rib structure. And there are design elements that you have to adhere to in injection molding that may not transfer easily over to additive manufacturing. And then finally, there's flow characteristics. In that, if you make a part out of polypropylene, for example, in injection molding, it's going to behave inherently different than an FDM part made out of polypropylene. So just because you can doesn't mean you should. So how do you combat the legacy versus additive and vice versa? How do you deal with additive that needs to go into a high volume production setting where you're going to be making 6 million parts that isn't suitable for most of the additive manufacturing areas? You have to be conscious of design rules. In additive manufacturing, typically you want to have commonalities in your part walls. In injection molding, you want the commonality in your part walls, but you also want to be conscious of flow and short shots. So it is something that software is inherently part of, because you need to design your part and then decide what's going to be the best fit for the part in terms of additive manufacturing, whether it be a fusion method like MJF, an FDM method such as the Stratasys machines or the myriad of other choices that we have, or a laser sintering method or something else. So when you design the part, I used to call it the 4 legs of the table. Glenn Beal taught me that. You need to look at cosmetics. You need to look at strength and physical characteristics. You need to look at speed and cost. All those things have an impact on your design. And only whenever you consider all of those things, and if you get 3 out of 4, you're having a really good day. But all those things impact your choices. And those choices will decide whether or not it's appropriate to use additive manufacturing versus a traditional legacy manufacturing. I hope that helps anybody. And if anyone wants any questions answered about that, just get hold of me through the chat or through LinkedIn. I'd be more than happy to refer you to experts if I can't help you out with it. But my job is really to help you make better choices and give you all the questions that come in on those choices.
Jennifer, Angelique, I'm sure you guys have more things to add to that.
Yeah, I think it was a great intro, Barbara. Thank you for that. And it makes me think of the product definition side, which is where we work, and we do that in 3D and not in a drawing. So, and for additive is a great spot to explore 3D product definition. because of course making a drawing is just way extra effort because you're gonna put that model directly into the 3D print. So I liked what you were saying about the fact that, if you think about the design of the product in conjunction with how it's manufactured, that's really, really important. And when you're applying the product definition, you kind of have to have an inkling of the manufacturing methods as well, because it does inform what tolerances you put on your part and if that's going to work on the flip side. So that's certainly true with the additive manufacturing space also. So yeah, that's my advice for that one.
I want to build a little bit on both inputs from Jennifer and Barbara. I think at the same time, I was thinking of it conversely. So often when parts are designed for traditional manufacturing, engineers have certain kind of requirements in mind. The principles of the technology are different, right? But for certain applications, for certain components, there might be also the chance that additive manufacturing provides the possibility to develop the parts or to produce the part with less stringent, for example, tolerances. Always what is defined based on traditional manufacturing that has to be applied in additive manufacturing. And without the insights of these trade-offs, engineers might miss the opportunity, and particularly engineers driven by, for example, cost considerations, to use additive manufacturing because they're not fully aware of the trade-offs, and hence they can miss the opportunity to reduce weight. I have in mind a very specific case of a client. They used to have a component in always CNC'd in tooling steel. For this specific application, they could use in additive margin steel. It was just as good for this case, and they were able to slash the cost to half, and also to reduce lead time by 2 months, just because the switch of material in 3D printing was good enough for the application. And yeah, nobody had thought of this option because the principles were of traditional manufacturing. So the question is also, how do we give to engineers this kind of visibility on what are potential trade-offs, but also what are potential wins they can have by switching to additives? So there's a lot of knowledge that engineers will need to stay up to speed with. And I think that's where software can come in and can bring, for example, in an automated way to the limelight this kind of trade-offs, but also this kind of benefits. The way we're kind of approaching it at Castor is we give these insights to the engineer, meaning we start from material selection. So based on traditional manufacturing material, we identify which printable material is suitable. We provide this kind of insights at the property by property level. And then we are also providing this kind of geometry assessment to understand if there are any risky areas in the part, if any reinforcement is needed, or if any redesign. Ultimately, it's the engineer who will take the decision, but having visibility of all these parameters can make his or her job much easier, and also help him or her not miss the opportunity to benefit from additives.
Oh, I couldn't agree more with that. And in fact, so many times whenever I see a design, I'll see people, they'll put 6 decimal places on it for accuracy. And, we've all seen it. We all shake our heads at it going, just because you can doesn't mean you should. But a great example is in the metal additives manufacturing side, inserts. There is so many places that we can use it on the tooling side. And on the production tooling side, whenever I say, I go into a molding shop so many times and I'll see the workstations have traditional machining stops for the workstation components where they're doing, we used to call it green rabbits, where they would have parts that would go down on a workstation to check for inserts and such. Those should be 3D printed. You can save so much time. And you allow your engineers and your production people that can make money for you to do that instead of doing internal stuff. And it's the same principle. Software, especially whenever your engineers and your designers have good knowledge of material characteristics and the possibilities, can really add to your bottom line whenever you're doing selection and doing right fit. We tend to really be focused on what we know. Software allows us to expand our horizon to what the possibilities are. And that really makes a difference in looking at your profitability impact of what additive manufacturing can do for your individual plant.
So I think a follow-up question I have to that is that, when I was at Jet Propulsion Laboratory, one of our biggest roadblocks was selling the benefits of additive to, engineers that are completely trained in traditional manufacturing. And they'd, hand us a part and say, here, can you 3D print this? And I'm like, well, I can, but should I? And I wonder if you guys have any advice on how you really combat that of, we have decades of data on some of these materials traditionally manufactured versus, we're starting to get there in additive, but how really to sell that, it's reliable, we can use it for all these different applications and things like that.
Yeah, well, fighting that kind of mentality is like a daily battle at Action Engineering, because we're trying to move people away from their traditional 2D drawing documentation methods and towards something that's much more robust, both visually and human readable, but also, more importantly, machine readable, to leverage automation opportunities. It's excruciating, Julie. And exhausting. But we have a lot of, my colleague Rhiannon Gallagher is our chief business psychologist, and so we apply a lot of psychology to the team formation and dynamics, and work on the messaging, because sometimes it's tricky to find the right metric. 30% time savings, 30% material savings, whatever it is. So we really have to work on creating positive spaces, create on looking at iterative wins within the transformations. You gotta figure out, is it a good idea? I like Barbara's quote, just because you can doesn't mean you should. So that's it has to really be a dynamic, safe space environment between the team members who are working, so that they can say, well, is that something we really should do? Is that the benefit? Or, oh, that's really cool technology, but how is that impacting an automation workflow? Or is that benefiting the human reviewer of this information instead of making it much worse? So it's just like constant communication and reiteration. Yeah.
Oh, and think about if you're a sales guy, you're immediately suspect because you're equated to someone that lies through their teeth anyway. So, uh, I love the fact though that we've got such a diverse panel. Jet Propulsion Lab. It's like I'm over here going, that is so cool. And then Castor and all you guys, I'm just like overwhelmed. I love it. But you know, so many times folks forget the common sense aspect of additive manufacturing and manufacturing. You know, I read one time that 90% of all parts are used in assemblies, and they're not cosmetic. They're not on the exterior of what you're ultimately doing. And so they come back and they say, well, it has to have a Class A finish. Why? Is the customer going to see this? So why wouldn't you do this in tooling and 3D printing? Because you're only going to be making 2,000 of these. Why wouldn't you do it in additive versus trying to tool it or to do it in other types of methods? We forget sometimes just the common sense component and bringing that to the forefront. But there is an art to getting that in front of the ultimate customer, which is the guy making the decisions or the woman making the decisions. And thank you. There are more and more women making those decisions now. So I am immensely grateful for that, because I used to be the only gal in the room most of the time. But it is still something that has to be, people want to make changes. They don't want to be sold on changes. They want to do changes that are beneficial and have a logical reason versus being told to be making changes because it's logical. So I love the fact you've got a business psychologist. I would have loved to have had some of
Yes.
that insight
Yes.
whenever I was younger.
It's
But
so important, so important.
and I took a lot of sociology course about crowd behavior and influencing
Yeah.
when I was in college just because of that. But again, it is an aspect. We've got a lot of myths out there about additive manufacturing overall. We've also, unfortunately, had a lot of hype about what the technology can do. And that hype has sometimes fallen a little short of what the reality was that was experienced. And so there is a large wall of skepticism right now to overcome. And that has been a little challenging, especially in the last 2 years, I think, for all of us, because people say, well, yeah, I heard about that, but I don't believe it. And there's a lot of disbelief. So we have to be careful. But there's a lot of promise out there. We still haven't matured ourselves as an industry. We're still evolving. And it's kind of like some of these guys that have electric vehicles that you always plug it in to charge it. They're constantly updating the vehicle every time you plug it in because it's an evolving technology. Additive manufacturing as a whole is an evolving technology. There are no rules yet because we frankly haven't hit the wall of rules. So when you talk to people, what was true 2 years ago is not true now. What's true now will probably change actually in 18 months because the rate of acceleration of change is changing. So additive manufacturing, we got a little ways to go in believability, but we're catching up quick.
I'm really glad, Barbara, you talked a little bit about the hype, and what I've been thinking all along, and with the risk of being unpopular, is when we talk also about additive as an ideology, even as a goal in its own. In reality, it's a tool, and it's a tool where the ultimate goal is to manufacture things, and it's not going to be always applicable. So if we take a step back and we present it as such, as a means, and not as the goal on its own, I think already we increase our probability to gain attention, but more from an engineering perspective and the approach on that. I think what we have observed that works well, and this is something that we have also embedded in the Castor software, is to identify exactly that. When does it make sense? It's not, as we said, a goal on its own. So what are the economics of it? And the approach is to be very transparent. There are quantities for which additive does not make sense, won't make sense anytime soon. And there are vast difference between metal and between plastic. Making all these things visible to the engineers help them, first of all, for them to understand, build their understanding on the principles of this technology, and also be able to defend them to their management, who in turn would need to make investments, be it on software, being on more colleagues, more engineers to deal with additive. That's one side. That's the responsibility we have as an industry to explain these kind of principles, and this is also the approach that Castor takes inside the project, inside the product. But also conversely, we being prudent on that is important, but also we have a responsibility to help engineers and their decision makers think of sides that we are often don't consider, or we take them for granted because the world is built on very specific way when it comes to the economics of additive, right? So if we always compare production of this part to production of this part, we will miss the forest for the tree. There's so much benefits that are not top of mind because they're related, for example, to supply chain. With additive, we can skip the need to store very expensive inventories or to build very expensive tools. This is a different way of thinking. So we have to also make sure that we bring this to the limelight. And from a very human perspective and organizational perspective, I think we have to be realistic and understand that for organizations that have not yet fully invested there, they don't see the benefit. We need to start slowly with those champions who are going to be able to, first of all, themselves master, touch the success of this technology in delivering benefits, and then be able to spread the world internally. It is a little bit, I think, naive to go and try to transform an organization in the blink of an eye. And if I can say, maybe on one level up from a managerial perspective, as with every innovation, it's much more, the path to success is much faster when the vision comes from the top.
I think that's a really important point, and I think to what we've been saying about the hype around additive, right? We titled this talk, the promise of additive manufacturing in there of, what is that actually versus what has it kind of been touted as? And I think it's really important to draw that distinction of, additive is that tool in the toolbox. And I think, the reason we're focusing on software is that is a great tool to help bring some of that data to the forefront, bring those use cases to the forefront. And I'll throw in a question from the audience of, how can software play a part in assisting with considerations of environmental sustainability / issues? So how to use software to bring that to the people who are making these choices about additive manufacturing methods.
I feel like I need to ask for a definition of software. Are we talking about software that like controls the 3D printers? Are we talking about slicing software? Are we talking about CAD modeling software that goes into it? Or is it just sort of all of the above? Maybe?
I think it could be anything you would like to talk about, because I think
that's fair.
So
yeah,
go ahead.
go.
Yeah. I mean, obviously I can't resist to share a few thoughts on this. We, as I said, we are on the parts identification side, and I was talking earlier about the different considerations of additive, right? So we talk about the reduction of the need to store parts, perhaps also to transport parts, because you can print just around the corner or in-house. So the approach that we're taking, and it's just also maybe a part of the whole consideration on the environmental benefits, is that through the lifetime of a product, from material to the end of life, there are different stages that additive can entail environmental benefits. For example, CO2 reductions, that's the stance that we are taking currently in the product. And we are assessing, for example, where we reduce the need for transportation costs, when we reduce material that can be used and wasted, when we reduce even producing the part altogether because it's a spare part and we don't need to keep the inventory. So I think software can play a big role in all those very, very complex calculations that are included in these kinds of considerations that are also very situational. Where is this part produced? Where is the company? How is it used? So I think software has a very, very big role to play there, both from the calculation perspective, staying abreast with, of course, technological evolution, and ultimately being a the decision makers. So this is a thought on the identifying the opportunity, which is where Castor is focusing. But if I can share also some thoughts from my previous life. I was previous career, I would say, I was working on product design at a European level, at a European policy perspective. I think there is a very big work to be done from the industry on potential environmental benefits or impacts from the production processes themselves. I think we have the possibility and the opportunity to make things great from the start, kind of.
I totally agree. One of the aspects of traditional manufacturing, I'll give you an example, thermoforming. When you do thermoforming, you have some types of processes within the traditional manufacturing that create a lot of scrap. And whenever you make the tool, you usually in thermoforming, depending on the type of tool you're going to make, you're either going to be routing out the tool or you're going to be creating the tool, and you make scrap that way. But when you actually do thermoforming or vacuum forming, it creates trim scrap that is significant and it's costly immediately and long term because you still have to recycle the cost. But in terms of sustainability, sometimes we forget additive manufacturing allows you to combine different types of parts into one part. So it allows you to decrease the cost of the part production overall, as well as decrease your cost of quality. Because every time you have an assembly, you have associated cost of quality as well as a sustainability impact. So, in many regards, software allows you to have a sustainability impact, but it is difficult to measure in most cases, and it depends on how deep you want to drill that hole. It depends on how deep you want to dig into the associated cost of sustainability and environmental impact, as well as other associated costs that may be in your manufacturing aspect. Manufacturing is complex, and as someone that has done costing for parts, as well as kept the books for an operations, and if you ever want to get a hard introduction to how your math skills are inadequate, keep the books for a company for a while. Uh, it, I learned very rapidly that there's a lot of things that you have to do in terms that numbers never disappear.
Barbara, accountants do different math than engineers. I totally get it. It's so bizarre.
Yeah, it's like when accountants
Yeah.
come up to me and said, "You need to do this," I start to go, "Yes, I am not worthy. Thank you very much."
Totally
Because
good.
they
Yeah.
have skills that I do not have, but as a manufacturing manager, I've certainly delved into it. So sustainability has it. And it also transfers into other aspects of your overhead. I saw a question in the Q&A about how do you add in transportation cost, inventory cost, or the cost of returns into the cost comparison. You also have the cost of quality. You have the cost of tool up on the production line, as well as associated with cost with your labor market. And actually, there's just so many things that add into your production cost. We don't have time to cover it here, but I will tell you that additive manufacturing has a different set of cost versus traditional manufacturing. But it's usually, at least in my opinion, tends to be simpler to calculate versus traditional manufacturing because there's not as many moving parts to additive that have to be added into making a physical piece. It's pretty straightforward versus traditional manufacturing. You got a lot of stuff and a lot of factors that have to go into it, but that's my opinion. So that was kind of a segue into the other question that came up on the chat. So in terms of additive cost overall, there's a lot of moving parts, but boy, there's even more in traditional manufacturing compared to additive is my point.
I think that's a really important part. Yeah. Go ahead, Jennifer.
Well, yeah, sorry, I was gonna say it was a great point. I got all excited. And so building on what you both said, my suggestion here is a little bit more abstract. So when we use 3D product definition and we're eliminating drawing, we reduce the cognitive load of the viewer or the reviewer, whomever has to do the interaction on the shop floor with the data. And so we reduce the cognitive load because they're already seeing in 3D. Like you don't have to go translate to 2D and then flip it back around in your mind. And so it's a lot of cognitive load reduction we can have. And so in that process, they understand the part better and they learn it faster. So there's a time and labor savings there. There's also an increased comprehension of the product itself. So they don't tend to be as many errors. Now, the nice thing with additive is whatever you model in there, that is exactly what's going to come out. So I think when you move sort of those pieces to the left of the life cycle and they're not necessarily on the shop floor because you're using additive, you're reducing scrap, which is reducing, energy to produce parts that don't go anywhere, that go into the trash. And I think that's a big benefit. But you're also tightening the life cycle of the part altogether, which probably in your cost calculations that you were mentioning, Barbara, that takes an effect when you shorten the life cycle of producing a part. There's a lot of sustainability savings in there as well.
Well, I actually have a follow-up question, and this is mine for both of all of you folks, in that when I'm talking to designers and engineers and folks that are doing additive, one of the things that comes up, and it has to do with software, is that often they don't put in clearances whenever that part has to interface with another part. In other words, they'll put it right up against each other and don't have any, you might say, space, if you want to put it, whenever they're going to screw something together, for example. And they always are bewildered because just the mechanic aspect of putting parts together, you have to have a little bit of fudge in there for it to actually assemble because wall to wall, it doesn't have any area to go together. Are you still experiencing this whenever you have folks that ask you about design factors and additive?
Yeah, I'm just nodding. Yes, unfortunately. Especially when we go back to that tolerance question we were bringing up, right? If you're used to, tolerances that are measured in thous, right? Additive's not that exact yet. You can machine it down to that if you need it, which is a good, finishing is come a long way, and that's really important to factor into your cost analysis and all of that. But it's a different design scope, and then people are like, oh, but what do you mean I have to print the extra scrap to machine down to the finish I really want? So yes, I think that's a universal problem.
The tolerance stack up is still an issue, right? I mean,
yeah,
you're putting
absolutely.
together, so it's still a tolerance stack up issue. It was one of the things we really struggled with when we were writing the ASME standard for product definition for additive manufacturing, was around the tolerance aspect, and then how are you doing the quality performance checks on an additive manufactured part. There's a whole process control set of quality checks, but then there are also dimensional quality metrology inspection activities that have to go on as well. We pretty much defaulted right back to traditional measurement methods with additive parts, and so we didn't differentiate any tolerance syntax that was different, really, in additive manufacturing than it is from traditional manufacturing. So it's one of the things I like about 3D product definition, is that the product definition is what it is. Those are the requirements for the tolerance stack ups. So they don't change regardless of manufacturing method. So once you do that design, then you can provide flexibility to the manufacturer to produce the part however they want to, injection molding, 3D printing, whatever. And if those tolerances are properly defined per the standard, which basically makes it all turn into math, geometry, then you're good to go. So that's the key there, is that it builds very discrete, unambiguous requirements for the design phase, and then the manufacturing can happen as needed, depending on where you are in the world, different manufacturing methods available, as well as what the performance requirements of the part are.
Yeah.
All
Well,
right.
and for me, in because I typically am dealing with end users in whatever role I'm playing that particular day. One of the things that always surprise them is plastic shrinks. They always get surprised by that, and it's like on paper it's supposed to be this, and then when they make it, it's different, and there's always an element of surprise between the software and the reality. Um, So you still have to go back to you could 3D print a 42-inch length part out of polypropylene example that might be 13 inches wide and 2 inches deep. Making it flat, however, is gonna be hard. Making sure that it's exactly 42 inches when you after you 3D print it, that's gonna be tough too. So you I think software and shrinkage patterns, also in the different types of processes, are something that you have to be aware of. And in design, you always have to be aware of shrinkage and the effect of geometry on the part itself. You know, the old adage of if you want it to be flat and dimensionally accurate, you have to put geometry in it. So it's still one of those things that we constantly deal with.
Yep. Well, so I think we're running up right against time. So if everyone wants to give their last, 20 seconds of advice, and we can let everyone go back to the main stage if anyone has one more thing to add in. Alex, did I beat you to our time warning?
Hey, it's been great to be here. Love the panel. Love everyone that's talked today. Thank you for having me. Alex, great event. I love the economic track, always does. Julie, thanks for having me. And Angelica and Jennifer, connect with me on LinkedIn.
Yeah, likewise. Very nice to meet everybody and appreciate being involved in the panel and appreciate the questions that we got from the audience.
Absolutely. Thank you, everyone.